Hello everyone, I'm Alex from FTC Team 18172 Uplift Robotics, and this week I'm going to talk a little bit about material properties and how you can use them on your FTC team. Material properties are the foundation of a large portion of the analyses functions and some of the other topics that Nitin has talked about previously and will most likely talk about in the future, including all the simulations that he has demonstrated. The best thing about material properties is that they're really simple and intuitive, and all you need to know is how and where to access the tool. So when I say material properties, I'm really just talking about assigning a material to a part so that Creo knows how to calculate different simulations for the part, including density, weight, center of gravity, and inertia, which allows for dynamic and static simulations like the ones Nitin demonstrated, including the shooter demonstration and the topology optimization. Admittedly, this is quite simple, but it really is the foundation of a lot of the more advanced tools available in Creo that really can and should be used by students within First Tech Challenge. Material properties begin on the Model Properties tab, found under File and Prepare. The Model Properties tab drives a lot of the key functions of Creo and is one of the tools that you should get comfortable with if you're planning to use Creo heavily. Material is the first row and will open up a file explorer to the default materials directory that is set in your config file. A material preview portion that displays a lot of the key model properties is also displayed. If you double click one of the materials, it will assign the material to the part that you're currently working on. By assigning a material to a part, you have completed the first step towards simulation, and you can now calculate the mass properties of your part, which you can either do in the analysis ribbon back in the part, or in the model properties tool. You can find the same mass properties just a couple of rows down. A drop-down will appear when you open the mass properties tab, and you can then press calculate for a rundown on the part's volume, mass, area, center of gravity, and inertia. The value that most likely matters the most for an FTC team is the mass value, which can help approximate the full weight of your robot before physically building anything. This will help with a lot of the custom parts that you may use on your robot, which may be machined or 3D printed, or just anything that you know the material of. But a lot of the parts that you're most likely going to use are going to be commercial off-the-shelf parts, such as this Go Build a Channel. And those may not be of a known material, or it may be constructed of multiple different materials. In that case, you can use parameters to your advantage. Most likely, the company that created the part has provided a weight for the part, and knowing this weight will allow you to determine an average part density to use. Although the center of gravity and the inertia will be a bit off, this will at least allow you to determine a good weight estimate and a close enough center of gravity that it should be useful to your team. So I downloaded this channel from GoBuilda to use as an example. If you generate mass properties for this part, the default density will be 1, which isn't really useful, but by generating mass properties, certain parameters are created for the part which will help. Specifically, the PTC MP volume, which will be used with the known part weight to calculate the average density. In relations, we can use the density formula, which I hope all of you know, mass divided by volume, and equate it to another parameter, MP density, which is the density that the mass properties uses to do its calculations. If we regenerate, we can find that the density is now there and is used to do the mass calculations. And there we have it. However, in this case, there was a better option than this. If we had simply applied the aluminum wrought material found under non-ferrous metals here, we would have actually gotten the exact same weight that GoBuilda advertises the part as, along with all the other properties that are defined within the material that will really be helpful for other simulations. So as you can see, there are certain applications where making your own density might be more beneficial, as in when you know a weight and all you really care about is the mass. But if you're doing simulations, it might be better to actually come in here and find a close enough material so that you get all the other material properties along with it. Thank you for watching this video. Again, I am Alex from FTC Team 18172 Uplift Robotics. I hope you found this tutorial on material properties in Creo useful, and if you have any suggestions, leave them in the comments. See you in the next video!